Okay, good morning to all of you and welcome you all to the public lecture organized by the Geological Society of Sri Lanka. So usually GSSL conduct this type of public lectures with the intent of science dissemination and knowledge transfer among our society members and our undergraduate geology student and the general public. So today also we have organized a talk on timely important topic. So today's topic is current status of mineral industry in Sri Lanka with special reference to mineral exploration. So today we have invited one of the senior and experienced geologists in the country as our resource person. So after his talk, there is a discussion session. So participants can lively engage with that. Also, during his talk, you can type your questions and send through the Google Meet. Meantime, this talk is live streamed through the GSL Facebook page. Those who join us to Google page, Facebook page, actually you also can send your questions. So without taking much time, first I would like to invite the President of the Geological Society of Sri Lanka, Dr. Lalindra Ranavira, to welcome you all and to introduce our speaker. Sir. Sir, I think, sir, please, can you please switch on your microphone?
Okay, thanks.
Good morning to you all, distinguished members of the Geological Society of Sri Lanka, professionals, students, and our speaker today, Dr. C.H.E.R. Siriwardana, and ladies and gentlemen. Today, we are going to talk about the mineral industry in Sri Lanka, and we have invited Dr. C.H.E.R. Siriwardana for this talk. So, I warmly welcome you all for this session. And Dr. C.H.E.R. Siriwardana is also warmly welcome for today's session. Let me introduce Dr. C.H.E.R. Siriwardana first. Dr. Siriwardana obtained his BSc in BSc Honours in Geology in 1984 from the Department of Geology, University of Peradeniya. Then he obtained his MSc in Mineral Exploration from ITZ, the Netherlands, in 1997. Then he completed an MS in Geology in 2011 from Kent State University, Ohio, United States. After his MS, he proceeded for his PhD studies from the same university and obtained his PhD in 2014 with a dissertation entitled Characterization of Paleoclimate and Marine Processes Associated with Holocene Sedimentation on Chakchu Margin, Arctic Ocean. Dr. Siriwardana joined the Geological Survey and Mines Bureau in 1988, and he served there until 2020 with more than 20 years of long service in the Geological Survey. While he was at the Geological Survey, he worked as a geologist, and he held the position of Deputy Director Geology at 2 occasions. In 2018, Dr. Siriwardana became the Director General of the Geological Survey and Mines Bureau. While he was serving in the Geological Survey, he contributed for compiling many geological map sheets and involved with many projects, especially with concerned with mineral exploration in the country. Dr. Siriwardana has also served as a visiting lecturer for several universities, including Peradeniya University, Aruna University, and Maratua University. Dr. Siriwardana has also published many peer-review articles and contributed for many book chapters, including the Mineral Resources chapter in the National Atlas of Sri Lanka in the recent latest version. He is a chartered geologist and a member of the Institute of Geology of Sri Lanka, and is also a life member of the Geological Society of Sri Lanka, and was the president of the Geological Society of Sri Lanka in 2008. Dr. Siriwardana, thank you very much for accepting our invitation to share your so many experience in the mineral exploration field. So thank you very much, and hope everybody will have a fruitful session today.
Yes, thank you very much, sir. And Dr. Siriwardana, sir, now it's over to you. You can share your screen.
Okay, thank you so much. First of all, I would like to thank Dr. Lalindra, the president of GSSL, and Armapriya, and all the EASY members. And I think it's an honor for me to select me as the one of the key lecturers, and actually this is the second one. At very outset, I think I might admit that this is not my talk is not too much of technical things, but it's rather everybody can understand, even a layman. So this is actually about countries' mineral resources. Okay, now I will share my my lecture. Give me 1 minute. Please. Okay, thank you so much. I think everybody can see my presentation in the
Yes, sir.
screen.
Please
Can
go
you
ahead.
see?
Yes, we can see, sir.
Okay, and also I think you can hear my voice. Yes.
Yes.
Okay, excellent. Right. My topic is current status of mineral industry in Sri Lanka, with special reference to mineral exploration. I might discuss my topic under small few topics, subtopics, introduction and the mineral industry in China, Australia, and India. Just to compare, actually how the economy and GDP and world production ratings, how they are acting, the China, Australia, and India, what is their position. So I might add a small section on that. Then the mineral resources overview. I think as geologists, most of you are very familiar with our mineral resources, but I think there's certain other universities, I think these are very much important. So I might add some text also in this one with more text than last time. And as I mentioned earlier, this is not too much technical, but you can all understand this. And I would add the historical highlights and also the present status and the future, and finally the recommendations. Right. Having said that, now with the introduction, the mineral resources, as you know, is the integral part of our national wealth, and the mineral resources are accumulated long period of time, and they are of course non-renewable. Even forest reserve can be grown up by 100 years probably in a big forest, but mineral resources they take millions of years, and if they are consumed, they are finished. So we need to consume these in a more sustainable manner, right? So mineral resources are socially, politically, economically, and nationally important, and it stands merely 2% of our GDP, fluctuating between 2%. And out of these exports, gemstones are the bulk, 88%, ilmenite, 0.3, rutile 0.07. Likewise, graphite has some 3%, and vein quartz 7.6%. Like, okay, and as you know, mineral resources are mainly non-metallics and modestly in metallic group and poorly energy. And also, except for government-owned companies like Lanka Prosperity Limited of apatite and Lanka Mineral Sand Limited of mineral sands, and also Kahatagaha Graphite Lanka Limited, all the industry, mineral industry is totally privately owned. Okay, so just a comparison of our exports. You can see industrial exports of agricultural exports and mineral exports and unclassified exports in September. The first column is September, month of September 2019, and it compares with month of September 2020. And it says that we have only 3.3 US dollar million for that month, and in respect to 2020, it is 1.7, and nearly 50% drop shown in that one. And even the January to September 2019, on that 9 months, the total is 24.7 million, and it also drops in the same period in 2020, and the changes. I think this is mainly the COVID impact, but generally you can compare how small our mineral exports are in comparison with other industrial, agricultural, and unclassified exports. And our GDP now, this is the GDP comparison between January 2018 to 2020. And you can see the last, in our last quarter, our GDP is nearly 60,000, that is 2.1%. And the previous October 2020, it is 2%. And during this period, the highest is April 2019, that is 2.3%, and the lowest is in July 2020. I think that is also again due to COVID impact. And so we are contributing only around 2% of GDP in our mineral sector domain. So having said that, shall we compare this one with the world scenario? The three main giants in the mineral industry, China, Australia, and India. Now, China, they contribute, the mineral industry contribute about 9% of GDP in 2020. And also, they are in world production ranking. Now, China is first in coal. I think the China is the main, the highest, the producer of coal, and also aluminium, bismuth, mercury, tin, vanadium, zinc, in all these commodities, China is the first, the highest world production, highest in the world production ratings, and in petroleum it is sixth. And in Australia, minerals sector contributes about 10% GDP, and they have jobs of 240,000 in comparing with their population, it's a big one. And they are in world production rankings, third in coal, bauxite one, lithium one. They are the highest number, I mean the maximum, the production of lithium in the world, and the gas, natural gas is 16 and petroleum 13. Now, in comparison with these two high developed countries, now India contributes again a little bit more than ours. That's 2.2 to 2.5% GDP. But if taking from the total industrial sector, it is about 10 to 11%, and over 700,000 jobs are there, jobs in the mineral industry. And in the world production rankings, they are the first in thorium and second in coal. Likewise, you can see these things. Now, in these charts, we can see that particularly the China and Australia, they are very developed countries, how a large amount of contribution is made by mineral industries to their economy, particularly in comparison with India and Sri Lanka. Yes. And now these are some of the important minerals to Sri Lanka. Now you can see titanium. Again, China is the world production rank ratings first, and Australia third, and India 11th. Likewise, you can see in most commodities, China is first in those minerals related to imported to Sri Lanka, and Australia is also in the first few rankings, and India is also not that far behind, right? So this is very important. Now, we are going to discuss a bit about overview of our mineral resources. I think this is very familiar with you all, but I might add some of the key points now. Energy minerals, no energy minerals have been extracted. We have done some research, some exploration, but no extraction. Limited exploration for nuclear raw materials, and there are some presence of hydrocarbons reported in Mena Basin, but still yet to be developed. And hydropower, it is the main supplier of our power, electricity, and water. It's a mineral resource. And in the metallic group, under the metallic group, we have iron ores, calcium, and magnesium in the limestones. Limestone is actually non-metal, but in certain times, it's calcium and magnesium are categorized under the metallics here. And titanium, zirconium, rare earth elements in mineral sands, and minor alluvial gold, and still platinum. Very recently, platinum was discovered in the western beaches, but still the studies have to be conducted. And Siriwardana copper magnetite deposit is the only base metal find, that is, we have copper in Siriwardana, and serpentine bodies, Usangodo and MPTA ones, the two serpentine bodies around MPTA area contain up to 0.5% nickel and 1% chromium. Indicola Palace and Guinea Palace serpentine bodies. Right. The non-metallics, our main group is non-metallics, our industrial minerals. Now here, it include graphite, mica, vein, quartz, gemstone, and dimension stones. These are the export minerals. And then apatite, feldspar, salts, red earths, and clays. They include the industrial minerals of local mineral-based industries, and construction aggregates and laterites and design included after construction raw material. I think rock quarry, sand, river sand, gravels, and all these are under construction aggregates are categorized, right? Okay. So all minerals except graphite are actually mined surface pits and open cast mines. Like virtually, apart from graphite, we don't have underground mines. That is why we are pressing for countrywide airborne survey. In 1955, the airborne survey demarcated Penranda deposit and radiometric survey for the same identified most of the monazite related deposits in the Kaikawala area and also Singaraj basic zone. So that is why we are pressing for develop some sort of a high-tech geophysical surveys to be done for unearthing untapped subsurface mineral deposits. That's very, very vital. And we have done some work, but still it's not materialized. So you can see two maps in the left side mineral resources, and in the right side you can see areas exploration areas under the exploration license are issued. So if you compare these two, you can see in the southeast sector there are certain areas have been allocated for exploration, but 2/3 of the area is not showing any large-scale exploration project have been done. But we have limestones, a lot of vein quartz, feldspars, apatite, and all. Many things are in the this 2/3 north and east and central parts. I think we have to do this exploration, encourage the private sector to do more exploration work. We have some recent offshore sand mining actually in these days also that is highly, working out in the western coast. So now in the future, once we receive a very large area, we might be getting more areas for exploration, right? Some historical highlights, I might not go deep, but just, 1900s, we have gemstones, iron, gold, and graphite industry. These are British era and even prehistory. We do gemstone mining and some sort of iron ore. Actually, iron ore now, even if we go to Penranda deposit, we can see still these smelting of iron. Even the British era, after British era, iron ore smelting was done in Penranda. So why not? Why not we do encourage small scale mining and developing? I don't know. And during 1900s to 1935, we have First World War. We have a graphite peak, and Ananda Kumara Swami in early days identified marbles and quartz developed salt at sound water facilities in early days. And Jaffna limestones were studied by Davis and Wayland, and Jurassic beds were discovered in 1925. And geology of Ceylon, there are two important monographs done by Adams and Ports in those periods. And during 1935 to 1960, this is the period where you get a lot of mineral resources have been identified and a lot of contributions to the economy of Sri Lanka, and also now this includes cement raw materials, mercantile clays, kaolin, gold clay, monazite, actually southeast, and even in the Katugurunda, there was a monazite plant. And a lot of particularly the Fernando and Wadia have done great studies. I think you have already recalled these things. So some of these important studies are very well recognized in those days. Graphite, gemstones, minerals, and REE. A lot of good publications were there. And Ceramic Corporation established in 1955 under this Industrial Cooperation Act, and several corporations were established. And 1960 to 90, this is the era of corporations. So actually, this is after discovery, this is the time period where the main significant economic growth that by mineral resource sector. For example, now even in the ceramic industry, more than 3,000 tons of property has been produced initially in this period. And a lot of now you can see Geological Survey Department was established in 1962, and Department of Geology, Peradeniya, water supply, water resources, NARA, CRDC, State Mining and Minerals Development Corporation. All these were established in this period, and many deposits, iron ore, apatite, Siriwardana deposit 71, apatite 71. Likewise, you can see large number of minerals. Resources were discovered, and there was a rapid growth immediately after this one. The mineral sector, the corporations were very active, but in the later period, public companies at 1987, some corporations became public companies. After 1970s, 80s, this open economy came, and we had to compete with other overseas products. Right. In early to mid 1990s, retardation of mineral industry due to lack of government interest of privatized companies were reported, and also Lanka Mineral Sand, they suspended operations in 1992. So the Mines and Minerals Act was established in 1992, and GSD was restructured in 1993, and they now Geological Survey and Mines Bureau, they governs the Mines and Minerals Act. So all the mineral industry is almost privately owned by that time. And actually, Geological Survey and Mines Bureau, our geologists have done a great job. They have done a lot of provincial surveys. In early days, we discovered some big deposits, but in later this period, we find medium to small, but thousands of deposits have been discovered during this time. Probably nobody noticed this, but reports are there, and some prospectors, some developers, they came to GSMB and they took our data, and they developed some of these mineral resources. I emphasize that again, thousands of small to medium scale deposits have already been identified by GSMB. Stable, the mineral industry during this period, but recent decline. And some few more facts. GSMB administrators administrating Mines and Minerals Act, and we are empowered to map geology, explore mineral resources, regulating extraction, processing, trading, and exports. And also, since 1998, raw material exports was restricted, and value-added products are actually encouraged, right? Raw materials is not permitted except a few. So mineral investments agreement is to be signed, and BOI, they are making some foreign investments, and the mineral policy is finalized in this period. And you can see this chart. This was by Kure 1988, but you can see bulk of the mineral resources were identified between 55 to 75, and they continued afterwards. Right. Uh, Having said that, now I might give one slide of about to compare the world scenario. Now, mineral exploration during this period, in early period, 1900s to and 1940s, there are direct observation. For instance, even Mount Isa, like large deposits are found in this prospecting. But 1940s onwards, regional service includes indirect methods, mainly geophysics, magnetic and EM service for Canadian base metals, and also genetic models have been identified, volcanogenic massive sulfide deposits, sedimentary exhalative deposits. Likewise, variety of models are identified. So in 1965, the person now is still highly developing, like exponential basis. Like so, we have still been used various geochemical methods, particularly for semi-arid and glaciated areas in Canada, and also a lot of sophistication of geophysics, airborne surveys, remote sensing GIS, and also field-based IR like PIMA type small instruments to identify gold, spectroscopy, genetic models. So these were the general developments in the mineral exploration. Right. In early period, also geophysics applied to identify mafics and ultramafics by gravity surveys, and conductive massive sulfides bodies by resistivity and EM surveys, magnetics by airborne and ground magnetometry, ice covered Canadian shields, magnetics and EMs, likewise trans and EMs. So these are the major techniques. Now let's go to the present and future. We have a time constraint, so I might rush. So some of these facts now, graphite, we already know these things, but to refresh, our graphite is the world best, and we have more than 99%, and the oldest industry with gems, even in 1700s it was discovered by Dutch people, but in 1800s the mineral industry thrived, and during World War One, the First World War, more than 6,000 mines are there. We know about that. And the graphite occurs as veins, works and ports and disseminations. Particularly, I can remember when I did survey Kiram area in Hambantota, we saw a lot of disseminated graphite in this part, and 17, 18 clustered pits are there in graphite exploration. We will see in a minute. And we have these Bogala graphite, Bogala Ragadara and Rangala deposits. And the vein graphites are discordant, mainly east-west like perpendicular to the main structure, and they are concentrated at antiformal crest. This is a very good phenomena theory, almost accepted that antiformal crests and discordant fractures. And the current production is 3,800. But once the prices of graphite improve with modern technology, nanotech, we will be discussing in a minute. This amount is also very significant, right? So bulk is exported, right? Having said that, there is very minimal value addition being done for graphite. To maintain high quality graphite, blasting is done separately. So these are not actually real value additions, but certain degree we can say So a separation of super quality graphite by hand sorting, Karnataka mines, these ladies in a long period of time, they are very excellent in sorting a 99 gold, even plus by very quickly. This graphite sorting, micronizing, the powder size. So this is very important, and also froth flotation. Using froths, even very low grade graphite can be like 30-40% graphite can be concentrated into 90-95% by froth flotation, and fine powdered graphite making this specific surface area SSA required for certain high tech equipments. And also now the graphites are conformed to these various parameters like moisture, volatile, ash content, density. So these required by various graphite base industries. So they categorically conform with these parameters in producing their products. And actually, nanotech applications are now coming to the scene. Now we have already started graphene and allied products and expanded graphite and lithium-ion batteries and all. And I will come in a minute. Before that, I will discuss a bit about exploration. You can see the main belt, the 6,000 mines also located in World War during these days. So these areas are the main graphite areas. This is a belt, north-northeast, south-southeast belt. Probably this is the boundary between Highland Complex and one in this area. And this you can see algorithm map that is a very highly sheared, almost parallel. You can trace these for kilometers in a linear distance. Okay, right. So these are very important. I think the main graphite belt is from Karnataka to this area. You can see a lot of graphite, and we did mineral surveys, and we could see a lot of graphite in this area, along with a lot of minerals like quartz. Some quartz pegmatites are very high in this. Amethyst, a lot of amethyst in these areas, along with graphite. I think this is the same with these highly sheared rocks. And bit low in the central part, in the Ratnapura area, graphite as showings, but probably the syntaxial bend and anticlinorium system open holes do not press enough these for the graphite mineralization. But in the south, you can see again the Kirama, Varapiti, area, those areas, a lot of graphite in early days, 17, 18 pits in clustered in Kirama, Varapiti area. So in early days, it has been explored. So I think it is a good target for again for the exploration. And recently, one EM survey was conducted by Margosa with versatile time domain EM surveys, VTEM. They say, and Karasnagala mine was opened by Ceylon Graphite near Pashala. So this is a very good development in recent days. And having said that, this is the Bogle mine, one of the graphite type, not parallel at the bottom, but they're branching off at the surface levels. A lot of thin veins and thicker veins are down in Bogle. And Rangala area, it's almost like Kahataga, and this is the second group, parallel veins. You can see if you find one vein at the top level, you can trace it in the bottom. So the Kahataga, actually during my days, I think we want to fully re-evaluate the Kahataga mines with underground drilling. I think Mr. Nalin Silva, Mr. Guru Silva, and group, a lot of our geologists and Jaguri, and they involved with this one. I don't know what the current situation is. So Karnataka is the only government owned one, and once these graphene are developed, our graphite have a very high value. Now, these are the graphene, the one atom thick sheet of carbon arranged in a honeycomb pattern. And these are the world's thinnest, strongest, and most conductive material. And adding trace to plastics and metals, they can make much stronger and useful in microelectronics, LEDs, and long-lasting thermal foils. And Huawei are currently using this. And uh, Sri Lankan, actually, the Sri Lankan graphene, now they are taking graphite torag into the Karnataka, and they produce graphene oxides, reduced graphene oxides and functionalized reduced graphene oxides and expanded graphites. So the annual production is given. And also in the batteries, you can see how they are important in high capacity, fast charging, lightweight. So all these, so the graphene is one of the revolutionizing, I mean, electricity, electronics and electrical fields. So this is very, very important. Now we are producing graphene, and that is very important. And also expanded graphite, type of graphite intercalations, compounds of GI, that is graphite intercalation compounds, and they are also very important in airtight materials, oil absorbent, flame filaments, retardants, likewise a lot of applications. So we can be happy that our graphite is getting worth and getting prices in the world, right? Okay, so I have a limited time, so I might have to rush the nuclear raw materials. There are some facts are given: uranium, thorium, and potassium. So they have produced energy and color. The early uranium was used as a coloring agent. And 1960s, the power began, and today 11% of world electricity is used by uranium, and some crustal values are given, and we mainly Precambrian conglomerates and Witwater strand deposit in South Africa, where you get a lot of uranium, and uranium is also found in byproducts as copper and gold and phosphorus mining. Some of these explorations are given. I don't think it need to be discussed in more detail, but some of the key points now. In early days, Rutherford and Mercury and Bohr and several, scientists, they use our thorium ions. And Thomas Baddeley, railway superintendent, working in Colombo, Mahatara railway line, discovered these Baddeley Baddelite, and they sent samples to UK, and finally it was found as a new mineral for the world, right? Thoriumite discovered by Kumaraswamy. So early 80s, a lot of work done, and uranium in 1950s, again, airborne radiometric survey identified this Kudrimali and southwest of Aludgama into the area, some nuclear materials. And also in early days, monazite processing plant was established at Beruela, and it exploited about 450 tons of monazite at that time. So you can see some of these minerals of thorium minerals. Here you can see in monazite sands in Kaikavale area. Sometimes you have about 14% of monazite in this. So thorium, now I have to say something. Now, Uranium now, IAEA and all the world, high powers, they concentrated only on uranium, and thorium is less concentrated by probably because thorium is mainly produced by India number one and China. So probably that may be the cause, but that energy produced by thorium is more than both uranium and fossil fuels. So China and India now developing thorium nuclear power plants, and it is used for various products. And in this part, you can see where the thorium is present, and also pulmude and have 0.5 to 1%. And processing plant is producing radioactive zircon. In 2003, from 2003, it is separated from a private company. And also, there are recent surveys. The Geological survey has done a lot of recent surveys. During recent surveys in the northwestern part, northeastern and both these areas, we have identified a lot of uranium, radioactive nuclear raw materials. You can see the counts in anomalies in these areas. And 1983, GST with IAEA, they did a uranium survey and identified 9 anomalous areas. Actually, these are being investigated. And in 1997, NARA and with Canadian Geological Survey, they did some surveys. And during these surveys, 11 resource sites were identified with more than 170 million tons of sediments with 1.1 monoxide. These deposits are yet to be developed, right? So some of these recent surveys I just show you, this is a mythical area. We have done a lot of works in this area to identify mineralization in the north eastern part, particularly. So this and the team, they identified a lot of anomalous areas in north and east. And also, we received carbon gamma ray spectrometer in 2016. So this during 16 to 18, we did surveys in the island-wide, particularly in the central highlands, identified 3 deposits. So this is one of the deposits, this Naula Senagama. Actually, after discovery of this deposit, this was abandoned area, but the people, the AG authorities, they need to set up some families, some village here, but we discussed with them and we mentioned that there are some anomalous radioactivity and they have to relocate these village sites. So that is also mentioned. We are, I think, on the way of investigating these areas in more detail. This is now the Senagama area. Right. Having said that, I might have to rush again for these INOs. Although we have not recently developed up to the British area, the Candy period, local smelting, nutcrackers, the beetle nutcrackers were developed by, produced by our local people. Now, there are two deposit types of iron ores, hydrated and magnetite ores. And the hydrated iron ores, we have 50 deposits with 2.2 million tons at 55%. And magnetite deposits, we have over 65% iron, Panirandava, and also Vilagidara and the Servilla. The largest at Panirandava is 5.6. Now I will give you some highlights of the Vilagidara deposit. Now it's also banded iron ore with barite type. I think you probably heard about this data. Now, this is interbandic calcinized amphibolites and magnetic gneiss, and maximum thickness is 21 meters and only smaller deposits. So it's high dipping, tight folding, and less economical, they say. And in the Kanidanda one is a big, a larger one. Uh, it divided into four structural belts and blocks, and the D is the largest. It is at 3,220 meters depth, and the main host rock is calcinized with pyroxene amphibolite enclaves. So the 2 or 3 iron rich bands at the maximum thickness is 10 meters. What I want to emphasize is now Villagidra and Penrandau deposit both have been abandoned. Now, and actually, Penrandau deposit is being explored now recently. You can see some comparability with the same calcinizers, and the thicknesses are almost parallel at 21 meters, but this is 10 meters, but 2, 3 bands, it's almost the same thickness. So these are almost uh, same highly deep going, tightly holding. So these two, if you see the position of these now, the Vilagidra and Penranda are both in this area. So I think there may be some sort of continuation or even hidden deposit somewhere around this area. It's almost comparable. And also the mineralization, also pyroxene amphibolites, is also again compared with the mineralization at Siriwardana. So these three types almost same mineralogic calcinizers, pyroxene amphibolite with magnetite, the Siriwardana one you have copper, but these two, even these two, you have calcinizer, chalcopyrites and coal. And I know exploration, I might not go deep. Kumaraswamy discovered certain things. And I know Kranswas Buttala, there's another smaller one, was discovered in 1998 by mapping, and then Professor Senaratna developed this one, discovered it in 2001. And these are the tonnages. You can see the tonnages, the big, the block D, that is the Peniranda one. The largest one is 3.5. So the Peniranda one is structurally broken into 4, and only the largest deep one at 3.5 can be developed. Right. Having said that, so the Siriwardana copper deposit. Now, 3 prospects are there. That's Arupu, Kollankulam, and Block C, and we did some 76 drill holes, 8,000 meters. Meta sediments, authenizers, and migmatites are the main lithology. Narrow up to 20 meters, pyroxene amphibolites. Now, see here, this is almost comparable with Penranda ores, as massive lenses and which go 5 kilometers in the regional strike. Right, VMS and metasedimentary carbonatic origins are suggested, and 4 million tons of iron at 40% iron and 2% copper. So exploitable reserves are limited only to Aripu. So these are the main investigations. And in recent years, we did some surveys, the core samples. Again, we investigated and we did some gold surveys, and we found recent analysis confirmed inside gold in the drill cores. And gold is widespread in new economic value for the extraction of multi-elements. So there will copper, iron is there, and if gold is also there, then it can be developed as a multi-element. You can see in certain times it's smaller, 1,000 ppb means 1 ppm, but in recently it was shown that wherever pyrite is there, you have affinity of gold with pyrite. So you can trace, we are selectively selectively identified mineralized zones, and probably you can extract gold in these areas. But certain studies have to be now. This is some of the mineralized. Now, cellular deposit is subvertical, 60-70 degrees angle with several multiple mineralized belts. You can see in the map, and also some geophysical studies. And geochemistry, actually geochemistry is abundant because this area is highly agriculture lies, and so the Siriwardana is very contaminated, but still you can see certain high elements of barium and zinc and others here. So that is important. So finally, I might add something about the Kiruna deposit. Now, the Kiruna is very similar to it also has now Siriwardana has 5 kilometer length distance, and we have 20 meters is the maximum thickness, but they have one single vein of 80 to 120 meters. But we have several veins of 20 meters, and the main difference is the depth. Now, they have mined for 2 kilometer depth since 1890 and produced 950 million tons of gold. We don't know about our hidden, our subsurface. We have explored only 100 meters. Why don't we study further? Okay, so I have time issue, but so I have to rush some of these things. Now, vein quartz. Now, vein quartz is discontinuous lenticular bodies filled with quartz, and it's a natural free silica with more than 98% SiO2. Occurs mainly with basement at the post-tectonic fluids migration into dilational cracks. We did surveys in the Rangenia, in Vallavaya, our team, Japudi, Ali, Naga, and there are certain famous geologists and geologists were there. And we find that in-echelon pattern of these veins, in-echelon, right? Zigzag-like pattern that is also dilational cracks were filled by migrating these deposits. And so show, the quartz is showing this low thermal conductivity, piezoelectricity, and thermal expansion. These are some of the properties. And has wide range of industrial applications. I don't think we have time enough to discuss all these things. But in exports, earlier we have allowed them to export as raw, as lump, but now this lump is not permitted. But now still we permit for grit and powder size materials to be exported from. That is why we always say investors are encouraged to erection of manufacturing plants here. Why we export raw? Why don't we do some sort of refining here and for producing some sort of value-added product here? So you can see some of these important estimated quantities of main vein quartz deposits. Candy, Ambalawan's a famous one, steel mining, Kahagolla, Mahagama, Randenia, Humul, and Akrel. You can see these things, and these are the products. It is estimated that more than 1.5 million tons of high-grade quartz and export of raw materials and value-added product. Now, I think low-grade quartz, vein quartz is used for the tabletops, produce tabletops, and some of the mills, they use vein quartz. So certain products, certain applications are being studied. I think I'm not going to discuss, but there are a variety of new applications for vein quartz. So you can see that the main Galaha one, the largest one, you can see some clay minings also in this one areas, and this is a small one. So that is why we have done a lot of surveys and we have identified this type of small to medium sized vein quartz. Why don't we encourage people to develop these things, right? Medium to small scale, thousands of vein quartz deposits are there. Sabragamua, Uwa, and northeastern province and all these areas. Now clays, major ceramic clays are kaolin, bold clay, and refined refractory clays and local ceramic and paper industries they were used, and the borderless gum it is 5 million tons. It's almost finished, and Meteor is 350 tons, and you get other deposits, Iranamadu, Kalani, Balangoda, and these areas. Now, I have to mention this fact also. In 2016, our annual turnover for the ceramic sector is 43 billion, and export income was 10 billion. But ceramic products and glass products we import 160 billion. So that is the gap. That is the gap. So why don't we encourage our local people to import and restrict these imports, because otherwise we can't survive as a nation, right? So some of these main clay types are given. I'm not going to discuss all these: kaolin, bold clay, bentonite, white clays, and brick-and-type clays. And meteor deposit was the kaolin, night, and quartz. It has very good well crystallized kaolin. Tropical weathering of pegmatite, pegmatite and granulite basement at Meteor. Meteor, you have this semi-precious gemstone of feldspar. It is also being mined in certain parts. It's a low-lying swamp and marshes, and there mainly you have iron and titanium. They've been treating for removing these titanium iron with various chemical products. Yeah. And also XRD identified rutile, goethite, and graphite are the main impurities. Refined kaolin is the porcelain industry. Now, bold clays are found in river floodplains in southwest, and the proven resources are 500,000 tons. And more than 50% of tile industry concentrated in Mahayo, and cement clays and Ralmaduach, Malay, and Murungkan. Actually, in Murungkan, we discovered bentonite. Actually, not ourselves only, but it has been reported that bentonitic clays in the Mahayo area. And GSMB conducted many kaolin bold clay surveys with Lanka Ceramic Limited and Ministry of Industries and Commerce recently, and identified new deposits in southeast part. So these are the this picture showing kaolin deposits at Meteor, and also you can see moonstone mining shaft in this area. Okay, construction raw materials, sand, gravel, rock, sand, soils, and estimated river sand production is 11 million cubes, and gravel and soils from various parts of the country. So for building materials, road metals aggregates, coating these, and our annual production is 12.0. And license numbers are 1100, and GSMB conducted. Actually, we are proud of, conducting island-wide surveys of, construction raw material surveys, We produce it in the provincial basis, and we have prepared these reports. Our geologists did a very good job, geological survey, and we have actually gave to the main GAs, government agents in the area to develop, to use for uh, various development projects. And also some of the facts, the offshore sand mining is currently also doing in very extensively, and it's an alternative for pure sand mining, and also some of these large floodplains, Somavati, Kantale, Annoy, and Valavi. So actually, it was unfortunate that until Annoy project comes, such a massive sand deposit was not discovered. In partly because not the civil war, but if we have airborne or some sort of a survey, geological studies, we could have identified these deposits. Not only we don't need to probably go for big, massive sulfide deposits in Sri Lanka, but we have these massive uh, sand deposits in this area. And manufactured sands are being investigated for a long period. And recently, 20% increase of the sand mining is there. Port City itself consumed 15 million cubes during this period. So actually, these sources are from Geological Survey, Minerals Yearbook. I have to thank them. And these are the correct. So you can compare the production of 10 to 11 million cubes per annum and Port City during these 2 years, they use 15 million cubes. And also a lot of quarrying, large scale quarries are developed, Ambantata, Begia, and varieties of our aggregate materials are being consumed with high. So some of the pictures you can see extensive sand mining in Kantale and in the Arnoyo, and some of the degraded lands in the this is also we have to admit that extensive mining caused a lot of damage to the environment, right? And dimension stones actually in various parts of the country we have used dimension stones in these areas. I am not going to discuss in a lot of districts you can see these dimension stones, particularly granitic, charnakite, granitic quartz, feldspar, gneiss, and particularly when you go to Rakwana area, there's a particular charnokite. It has a very bright green color. So I think there was a lot of inquiries that Rakwana green. They request for Rakwana green. That is very, very important. Certain types of rocks can be particularly developed as dimension stones. Unfortunately, they are crushed for the aggregates, right? Some rocks are very excellent quality for developing dimension stones. And the mica industry is very old, and during World War time, a lot of requests were made, and musquite and plogopite are the main, and the vermiculite, that is hydrated biotite, is found in certain areas. This is also very much important as the insulating materials. And mica is mainly ultra basic diets and marbles and pegmatites. If it's found in pegmatites, it's more random disseminated type, but associated with ultra basics are very important. We have done a mica survey in Matale area. We have identified a lot of veins, the ultra basic veins related to mica. These are excellent vein types, right? Okay. So you can see this is the Kambarawa area. You can see two types. Now the disseminated types in this this is the ultra basic rock. It's not in the daylight. It's not showing very well. These are disseminated in this one. and you can see a big vein, when a small vein found in the surface showing, they say Batala ilm, that is a sweet potato mine, it's only a thread at the end, very small thread. But when you mine, all of a sudden you get a bulge of this one. That is what you find very large vein type, right? So the ultra maybe cost rocks are the most important one. So there are some production figures are given and the prices are given. I'm not going to discuss. And so I have to mention that for the mica, sheet mica and scrap and flakes, our mica are mainly selected as scraps. I don't know why. Indian market, India is dominating in the mica market, and it's very difficult. It's on the few square inches area is the main factor, and our mining. Now, primitive mining methods are used. So the fresh rocks are unexplored. So veins are only found up to the overburden. So from overburden onwards, they just forget about mica, right? So illegal prospecting results in degraded land and certain resources abundant. So if you find a mica in certain areas, what they do is they put some vertical pits, and all the dumps are laid in the other parts of the vein. So they miss valuable resources because it's haphazard mining. Open cuts mining rarely practiced with demarcation of host rock. So this is, you can see the ultra basic rock exposed in this area. This is a big open cast mining in a market area. And postpays, actually, I am not an expert to discuss postpays. I have to admit that there are a lot of very recently, a lot of workers have done excellent job on the postpaid deposits. Dr. Pitawala and Professor Pitawala and Professor Khan Rajapaksa and Professor Ilekal. And I think I am not going to mention, but still there are. And also the pioneers should be mentioned. Siriwardana in 1976 made this only valuable book, a detailed book of this Epal deposit, so far available. And he described mainly geochemistry, right? So there are two, the Epal one and the small Kavisigamo deposit. And Kavisigamo is actually it's a local relief 2 to 6 meters high from the local ground, and crystals are very fine to tens of centimeters area. And primary and secondary phosphate minerals of phosphate, iron, aluminum materials, and XRD data says these are melodically same. But I have to say, it's not the place and not the discuss of the excellent work done by on the phosphates. But what you can see in the side is the carbonatite deposit at Palabora in South Africa, famous one. You can see the carbonatite here, and it's a cylindrical body, and around that you have alteration zones, and at the top you can see ring dikes and cone. What's that? Yeah, cone sheets. So this is the area where you get a lot of rare earths develop in this area. So the everywhere you get carbonatite, that means rare earth is definitely there. But I don't know in Nepal we don't have much uranium. In other in Alabora they have high uranium, but we have still yet to be done, because there is a saying that exposed intrusives are not important. Unexposed intrusives are more important, because every time unexposed intrusion means you get all these rare REE and other mineral rich shown at the top is preserved because it is not eroded. So that is why we have to look for REE related deposits also in this area. And there are now new uses of nanotechnology application, hydroxyl apatite nanoparticles for develop. It is very, very good that recent developments of actually my batchmate, Professor Gani Rajapaksa is volunteered with Professor Pitola and many workers now in the nanotech field. And also water-soluble fertilizer with microbial activity is being done studies. And also it is mixed with biochar. You know biochar, important. It's a pyrolysis of biomass without toxins, anguru. And this was used, since the Mayan civilization. They succeed with using biochar. You know, when biochar is applied with certain fertilizers, they absorb all the elements and release gradually. So it is very important of certain fertilizers releasing slowly is very important. Maybe that is a good application. So exploration is a power. I am not going to discuss these things in detail. And there's court case, Bulankulam was Ministry of Industrial Development in 2000, and it ordered to desist from entering into any contract until up to the time that comprehensive exploration is being done. And the CEA approval should be there. And actually, I am very happy that during my tenure, we have started exploring the power deposit, and the northern part has already been explored, and the report is being done, I think, in these days. And the southern part is also going to be studied. So the TSP production, the several times, even in 1978, worldwide, of course, the code was SSP, TSP, MAP, and DAP, all these soluble single phosphate, triple phosphate, likewise. So, one of the issues is the using of, you have to use high sulfuric acid for converting phosphoric acid for the preparation of the phosphoric acid, and that is sulfuric is highly environmentally bad substance. You have to handle very, very carefully. And so the alternative is SSP, I think now going on. World known phosphorus reserves deplete in 50 years and base reserves export in 150 years, they say. And sustainable exploitation needed for future development. Right? Okay, I don't know whether my time is going out, so, but right, I will do very quickly finish. So this is the northern part, and this is the southern part of a power deposits we develop. Right? Production figures are given. And the feldspar is, in the island wide, everywhere you get smaller deposits. A large number of small feldspar deposits have been identified by our provincial surveys. Known occurrences in Haputale Costa and the Alahara and Namalloya, largest at OL, and reserves of 3 million tons. And they are used in glass industry, in ceramic industry, plus and vitrifying lowering vitrifying temperature. Particularly sodium feldspars lower vitrifying temperatures of ceramic industry. When you apply feldspars, affect these corrosion resistance, and the glass is more hard. There are a lot of properties developed in the using of the feldspar in the glass industry also. Durability and resistance and corrosion. And feldspars have 14% potassium. 14% of potassium, sorry, here. If I have 14% of potassium to be used for produce K fertilizer treated with calcite and HCl in microbial activities. A lot of researchers that are going on for developing potassium fertilizer from feldspar and silica sands. These are best developed in Northern Maravilla and Madampi areas. Unfortunate thing is once these sands are mined, you get a lot of degraded lands, so we have to think about that. Isolated pockets of occur in Ekala, Dalus in Nepal. Actually, Dalus in Nepal deposit was discovered by ourselves in 1997. Unfortunate thing is during recent sand scarcity, valuable glass sands have been because glass sand prices are low. So valuable glass sands have been used as construction sands. Fine grain, white and high purity, and total production is locally used and export is not permitted. And there are silica sands in A color. I think Somapal and Fernando have done a good survey, good study, and they found that this color started wash out of iron coatings of clays with acidic waters. Mining is carried out by limited license holders, and total production is that much. Okay. So I have a few slides on marbles. So marbles are, marbles are mainly developed in Central Highlands, and our marbles have magnesium content 16 to 21%. Best known in Digana Talatu Matale. Annual production is that much, and the green, serpentine marble at Rupa and Trandania deposit magnesite. That is also important, and there are a lot of products are being developing by crystalline stones, and the Miocene limestones and the northwestern belt by this biochemical origin more than 95%, and proved 90.4 million tons of limestone in the Aruakaru in the Putlam, and the best known deposits occur in the Jaffna over 250. I have to mention that in recent years, GSMB has done a very good drilling survey and developed certain, I think, Mr. Dharani and certain other Mr. Jaguri and our geologists. They have done a good job, and they found thick limestones in Miocene limestones in this area. They have to be studied, and these are the limestone bearing pelts and Miocene limestones. You know about these, and calcite deposits. Calcites are found as within marbles. During our North Central Province mineral survey, we discovered a very good calcite deposits in Mahailu Parliament and the Gamay. That is a home beds folded, very nicely folded. Within marbles, you get pure calcites. Still yet to be developed. These are very important. And also bulk of production currently found in Balangode area. Annual production is nearly 50,000 tons, used as a pillar and rubber and textile industry. And local requirement is not met. Existing product quarries and export is not permitted. Thermic products are not permitted to export. So these are the coral and shell-based deposits in Akurala, Hikadu, and seashells at Hungam. I am not going to discuss. So these are the areas of shell beds in the southern part of Sri Lanka. And these are the quality requirements for limestones. You can see in the sugar industry, 94% calcium carbonate, chemical industry 95, paper industry 98%, metallurgy 95%. So these are also important for various requirements. So these you can see limestones in the and the coral. You can see coral beds in the around, particularly southern part, southeastern part, and the northeastern parts, and also Manat and in the Kalpiti area. And nanotech, calcites, particularly nanotech applications of NPCC, that is nano precipitated calcium carbonate and calcium carbonate nanoparticulates. So actually, there are some researches are being done now. These are developed from calcium carbonate encapsulation of nitrogen fertilizers. One of the problems is nitrogen fertilizers are very highly soluble. So when you put this, there's a lot of waste. So if you add these things into this sort of porous, nanoporous particulate matter, then you can absorb it very slowly. So that is very important. And also acid neutralizer. So, if you go to the southern part of Sri Lanka, you can see a lot of degraded lands. Probably calcite can be used as this neutralizer. And also, it's a medicine. Chewable plants tablets are produced by this one, and it's a solvent. It's capture any substance during burning with fossil fuels. These can be used, and monument and sculptures, precipitated calcium, extremely white, used as a white pigment of whiting. Papers, photocopy papers, and others. There are several applications of precipitated calcium carbonate. Why don't we think about developing our valuable calcium carbonate and dolomite resources for this industry? Yes, my senior batchmate, Mr. Kumar Singh, developed these nature secrets, and some scientists develop some of these soaps. And so there's a lot of products are being developed by a scientist. That is important. So beach mineral sands, actually pulmonary deposits, we have ilmenites, these ranges you know about, and deposit extend from Nilal to Kokilai and nearby deposits. This actually sometimes it is 6 million tons, sometimes it's 4 million tons, but I think yeah, and the around with around 1.7 million tons. So this much of ilmenite, rutile, and zircon are there, and also 3 new deposits were discovered. And also, this one is important in the northwestern part, trade beds in the Putlam area. These Iluka resources in earlier, now they are Putlam ilmenite. Yes, their name change. So they have over 1 billion tons of sand with 7 to 8% heavies, right? I think I can still remember their project proposal suggests that $200 million per annum is their expectation to in developing this one, right? So there are a lot of others in the Bay River Calani. So there are a lot of minerals and deposits. Zircon is used for zircon metal, and garnet is abrasives, and RE is actually titanium metal and titanium dioxide with the 2.55 Ri. It has a very good properties for titanium dioxide, thermal properties and color retention, and opacity very high. The first thing is, in America also the lead bearing paints are being rejected, and nobody gives even rent a house if lead paints are applied. So alternative is titanium paints, right? lead paints are toxic. So now they are replacing by titanium paints, titanium related paints. London, particularly Lanka Mineral Sands, they are going to set up a mineral sand plant in Kokilai. I don't know. The EIA was completed, but I don't know the current situation. Also, value-added products for ilmenite like synthetic rutile, metal, titanium pigments, and alchemy heavy minerals purchase non-metallic tailings in these areas. And finally, gold and right. Gold is prehistoric, and even there was a gold rush in 1938. That was actually 1850s. There was a gold rush reported in 1938, and Disanaik has found closer relationship the different gold mining villages with Run Pupics with the modern geological data. And Dixon, gold expert, found that alluvial gold in central these areas. And GSMB surveys 2000, they found high amount of gold in the upper reaches of Balawi in these areas. And Gold Rush 2012 discovered small nuggets, Kumari, Mulo, Vitigama, this area. So GSMB has carried out a stream sediment survey in 95 areas, and 21 ppm gold was discovered. Actually, our survey found some of these so far unmined gold in Bogoda, Kalani River, in the southern parts. Mining is going open. And in our survey, the upper reaches of Sita, Ganga so far not being mined for gold is there. And the next phase is, gold is not migrating more than 5 kilometers from its source. So we have to check for these Kalani Ganga gold source, right? Actually, that was the aim, but we couldn't complete it due to COVID issue. So these are the river dredging. From the rivers, they dredge gold and gemstone. And this is a GSMB survey. You can see Mr. Ajit Prem here. Yeah. And this is the Professor Disana published this valuable paper in 1985. He identified main gold occurrences around Ratnapur. You have a cluster, and there are many in other areas. And this is the gold pan. In the gold pan, at the center, there's a small pit to recover gold. That is important. So these are some of the gold grains we find in our survey. This is the gold rush and local furnaces. They use mercury into this one, and they burn very environmentally not friendly with these sort of activities. But mercury burning in open air, and they're making of amalgam, and these are some of these recovered gold. And gold exploration, these are the main gold deposits like greenstone belts. Then you have reduced intrusions, orogenics, and variety of gold deposits in the worldwide. And in recent years, in the world scenario, they have applied various geochemical methods like stream sediment geochemistry or pine paction. This is a common, it's not new, but it's old, but still they are using. And bridge, that is bulk leach extractable gold, and cyanide leach, and pan concentration of soil lag and rock chip sampling, reduction oxidation potential and microbial populations in soil gas analysis, halogen concentration, isotopic compositions, strontium yttrium ratios of whole rocks and apatite fusion tracks, and less ablation ICPMS for questions like, and the geophysical methods like gravity techniques for prospecting gold, that of gold-related hydrothermal alterations, airborne gravity gradients, magnetic and radiometric methods, and 3D immersion, potential field data, seismic service. So there are a lot of new techniques for gold determination. Remote sensing and field-based infrared photography for gold exploration. Now, this is not only gold mineralization, but also alterations. That is very important. Alteration mapping. We also have alterations, not that big, but even with the graphite mineralization and certain other mineralization, you have certain degree of alteration, not like the sedimentary terrains, but this is significant technical advances in infrared spectroscopy for alteration mapping, and also satellite multispectral systems like ASTER and airborne hyperspectral sensors like HIMAP, and spatial resolution and high signal to noise ratio and wide spectral range coverage. And field portable hyperspectral instruments such as PIMA have become a standard tool for alteration mapping, first introduced in the 1990s, right? Okay, various field portable protocols have allowed data collection faster from core chips, parts, and remotely from outcasts or constraints. Okay, improved capability of mapping alteration zones. Okay, so now I am coming to the final part. So among the other mineral resources, the dune sands and red beds and carbonaceous shales and shoals. I am not going to discuss that in detail. And also topazite, polactor, and rose quartz. There's a lot of others. So finally, my recommendations are right. Mineral exploration should be promoted to identify untapped deposits, especially for export minerals, including gemstones. That's very important. Even we did some surveys in Yakalamulla, where beryls are mined from weathered rock. Why don't you explore this area and finding how where you find pegmatites of the similar nature in this area, and if these weathered pegmatites are found, then definitely that's very well economical. And not only so, gemstones are one example, but all the others, particularly we have lack of foreign exchange now, so main minerals can be identified with mineral exploration, and we have to do reserve estimations and evaluations of the mainly identified deposits. We have thousands of mineral deposits identified by recent surveys, and if the large and medium scale deposits have to be evaluated, and mineral-based industries should be properly monitored to enhance productivity. That's also one feature. In 1990s to 1995 or so, the lack of monitoring caused, retardation of these industries. Value-added developments expanding mineral-based industry should be encouraged, particularly for small, medium-scale deposit using. And nanotech, my friend, my batchmate, Rajbaksa, and and a lot of workers are now in nanotech. We have not big deposits, but thousands of small to medium scale deposits. So nanotech is, or some other advanced technology is very much important for developing these deposits. Mineral imports should be minimized. It's very unfortunate, as I mentioned. Ceramics, while we are exporting 10 billion, we are importing 160 billion. And also, our iron ore. Do you know the amount of iron ore we import? it's 1 million tons, according to our mineral yearbook. Over 1 million scrap iron and various categories of iron are being imported, while we have our iron ores in Sri Lanka, at least up to British period, local people developed these. Airborne geophysical surveys have been conducted to locate subsurface and near-surface deposits, but not only subsurface. We have only 1 or 2 graphite-based underground mine, and virtually our subsurface was unexplored. And even bigger sand deposits like Yarnoya and others can be identified, and even the landslides, bigger landslide prone areas can be identified by this sort of geophysical airborne surveys. And high quality products need to be produced, competing with the countries, and illegal mining should be minimized for all mineral explorations, and investors should be encouraged manufacturing plants to establish here. Okay, I think with this I conclude my lecture. Thank you so much, and I think I have already taken a bit more time. I'm sorry about that, but I think the things we discuss is important to you. Unfortunately, time does not permit to discuss all these things in more detail, but I think thank you so much for listening and participating. Thanks.
Yes, thank you very much for your very interesting and very impressive talk. I think now we have time for a couple of questions. So participants can ask your question.
Dr. Siriwardana, could you hear me?
Yes, yes.
Okay, I'm Nalin Disilla. I have a couple of questions. First, as many other aspects, we are living in the history, because all of the many of the findings, explorations was concluded at the GSD time. And since then, it means last 25 years, we haven't found any significant mineral resources in Sri Lanka, because what we have done already known deposits, we have just tried to quantify these things and so on and so forth. But compared to what the GSD did, we haven't found any significant discoveries, either quantity or qualitative wise, since the last 25 years, except recently, I think in Professor Atula Senaratna managed to find some of the graphite occurrences in C.H.E.R, because it is a bit out of the context. Apart of that, we haven't found any significant mineral deposits occurrences. Is it the policy decision of the 1992 Act, or what is the reason for that?
Right. I think I have mentioned the reasons also during my lecture. The one thing is, we have done a lot of provincial mineral surveys, and we have discovered thousands of small to medium scale deposits. I think if you refer Sabargamuwa reports, Northeastern Province reports, NCP report, and others, there are a lot of smaller deposits, because we need some sort of, geophysical or some sort of surveys to explore our subsurface. It was unfortunate we have only 1 or 2 graphite deposits with the subsurface. All the other areas have still yet to be not identified. So the one thing is that, and probably there are a lot of small deposits, and I don't know because Sri Lanka is not a very big country like in Canada or Australia. We are still larger deposits can be identified. Some of the major deposits have already been identified during our prospecting time, and initial surveys. Yes. I think in the future, so you don't have to be rely on the prospecting, but we need to apply more detailed, methodology and techniques, advanced techniques to sort out and untap, to sort out mainly the untapped deposits. I think in the future, you and other scientists have to be pioneers to get these things done for Sri Lanka. Yes.
Okay, small clarification, because as you already explained about graphite exploration, since last 10 years, all the prospective areas for graphite exploration has been fenced out by third parties. I mean, different companies, different individuals, last 10 years. But what has happened? Because if it is for exploration, last 10 years, they have done nothing. So it means there is a failure of the system. I mean, the
Yeah.
exploration system is not working as we intended.
Right, excellent. Yes, I think so. Actually, I don't know what Margosa has done with this VTM has done out, and Sunday they did some airborne survey and what is this? Main thing is the monitoring. Even the corporations when they turn into private, quantity. Companies in in early 2000s, in that period, that was the main problem was not monitoring. The management in early days, the early corporations in 1970s, 80s, that was excellent because a lot of production, a lot of activities. Government is very interested in these days, and the government interested was dropped, and monitoring was minimal. Unfortunate thing is Kartagaha and others, so I think whoever the authorities, they have to think sharply and considered very keenly on this monitoring part. And as you suggest, yes, our system has some issues. Right.
Okay,
I think it is the time for you
yeah.
and others to rectify in the future. Right.
One other question, because you explained the sand mining in lower Penny Plains and particularly in Kantale area, but if you consider the Kantale and say from Siriwardana onwards, the level of the bed level of the river is almost close into zero. I mean, mean sea level, and that system usually produce about there are 25,000 hectares of paddy. This saline water intrusions and bank winding and all this negative impact is there in the lower Maha Valley. So I think, as I done a lot of studies in lower Maha Valley, and we are preparing a dynamic model. The Yango is a different story because it is a reservoir bed going to be already inundated. But if you going to propose sand mining in lower Maha Valley, lower Malwa also, no problem, because there are going to be a reservoir. We are doing a lot of studies there as well. But mining sand in the lower Penny Plains, in particularly places like Verugal and Maha Valley mainstream, going to be a disaster. So we have to be very careful. This is not a question, this is a comment, because
Yes,
our study says that it's going to be a disaster.
Right. Thank you, Nalin. I think it is same. I have already shown you, I think, this Ma Oya, what happened to Ma Oya. Certain loops of the rivers are joined now, and the Ma, it's very unfortunate. Sand mining has a lot of not only sand, but also all the construction raw material mining
Yes,
is problems, and you have to be monitored. But whatever it is, we have to explore the areas. We have identified the reserves, and in the case of mining, we have to consider all these parameters and issues, and the allow only acceptable areas. Right.
Okay, I agree. Thank you.
Okay, thank you, Mr. Nalin. And any more question? So there is a question actually we received from our GSSL Facebook page. Mr. Suresh Rasnayaka. His question is, actually he asked the existing procedure to obtain graphite exploration license and graphite mining license. I think you are well aware about that. So
Yes, I think it's not the forum.
yeah,
I
yes.
have to answer this, but you have to contact our mining division, because the time to time these regulations and these things. I mean, various administration decisions are being changed, and get the most updated version. I think you have to contact the GSMB mining
Oh,
division. Thank you
yes.
so much.
Thank you.
Let me ask one question,
Yes,
Dr. Siriwardana. First, thank you very much for your very descriptive talk. Now, we have a large wealth of mineral resources, mostly smaller scale. So, to start with the smaller scale industries, what are the barriers in the country, maybe in technological wise or administrative wise? Based on your experience, what could be your comment?
Yes, actually, in both, as a GSMB Director General, former Director General, I think I should admit that it is sometimes as a layman or the artisan who intend to mine is going on with experiencing a lot of issues and difficulties with the government setup. There are still there are certain things have to be eased for the considering the people, that is there. And that's not only for Sri Lanka, but also in the other countries there are certain issues, and also technology. Yes, that is important. There are, do we really get the value of our minerals now? We were exporting tons of graphite in earlier days for just $1,500 to $2,000, and we are getting the same for 1 kilo now for graphene. So there's a value addition in one part. So we have to think about that, and the generally there's a belief, even in America, they say the university system and the industry has a gap between 5 years. Those who find things in the universities materialize only after 5 years. That is the normal practice in area. So I think some of these very good things, lot of nano tech and other advanced technology practices are there. I think their knowledge, their advanced technologies, low-cost methods, and these things have to be materialized with, go to the common people, common man with the time. And I think GSMB and other authorities have to facilitate and they have to identify the barriers. And in the same time, there are a lot of illegal mining and done by people. And once you give some lapses, not lapses. If you give some support, sometimes in Sri Lanka, in certain people they misunderstand, and they always trying to get the maximum exploitation, not considering the environmental, very critical environmental concerns. That is also we have to be balanced.
Yes, thank you very much, sir.
Thank you.
I think now we have reached our time limit. So for the time being, I would like to wind up the session. So I'm grateful you again, because I'm grateful for the time effort you took to share your knowledge, thought, and experience with us. On behalf of the Geological Society of Sri Lanka, please accept my sincere appreciation.
Okay.
Meantime, I would like to thank Ms. Nilmini Taldena and Dr. Upul Premaratna for coordinating this public talk. Also, all the executive committee members of the GSSL are acknowledged for their support to make success this event. And finally, on behalf of the Geological Society of Sri Lanka, I would like to convey my sincere gratitude to all participants for their participation. I think we had a very fruitful session with Dr. Siriwardana. The live video, actually the recorded video recording relevant to this talk that is now available in our webpage also. Hope to meet you again to another GSSL talk.
Thank you so much. Thank you so much for inviting me and all the questions asked and the participation. And it was an honor for me to give this opportunity. Thank you so much, Dr. Lalindra and Dr. And Secretary and the committee EC committee. Thank you. Thank you.
Thank you very much.